Hello everyone, my name is Karla Ahumada, and today I'll be covering all about randomized complete block design. We'll cover a quick outline of what you will be learning today, the introduction, what is RCBD. We'll be comparing RCBD to another type of experimental design, which is CRD. We'll be showing you how to design your own RCBD experiment, as well as that once you've collected your data, how to analyze that data through ANOVA on Excel. We'll provide a real-world example before we set up an RCBD experiment, and lastly, we'll cover a summary to reflect on what we've learned. So what is RCBD? RCBD is a type of experimental design in which the experimental units are grouped into blocks based on a characteristic that can influence the outcome. So what does this mean? It means that out in the environment or out in the field, it's facing something that can cause change within the data that we do not want. So we know that our treatments might cause differences in our data, but there's this other aspect or variable that could change our data that we do not want to analyze. And so this means that we'll be dividing our plots into blocks. Each block receives all the treatments, and this is a type of the experimental design that is typically used for field research in which conditions can't be controlled. And then our goal is to reduce the experimental error. So again, we don't want our data to be influenced by exterior factors that we are not analyzing. And so I mentioned CRD. CRD stands for completely randomized design, which sounds very similar to randomized complete block design, but they're very different. So RCBD has randomization within blocks. Our CRD has no blocks and it is completely randomized. RCBD has a known source of variability, whereas again, CRD does not. RCBD is typically used in outside conditions that can't be completely controlled, whereas CRD will be used in inside or perfect conditions like a laboratory or a greenhouse where you can, perfect the temperature inside. You can have all your plants in the same level. And then RCBD, once we check out their ANOVA table or their analysis of their data, you'll see that there's 3 sources of variability, again, because out in the world where it can't be perfect, it has more characteristics that might alter the data, whereas CRD only has 2. And we can check that out at this table, and you can see that the RCBD ANOVA has a treatment, a block, and a general error as a source of variation, whereas CRD only has 2, and that's the treatment and the general error. So let's get off on how to actually design the RCBD experiment. And first, you want to find a field to work on. And you're going to identify how to make this field uniform. So the classic example is that you have a hill. And so the conditions that your top area of the hill faces will be different from what the bottom one faces. And because you don't want anything that might alter your data besides the treatment, you want to spread your treatments equally through those blocks. And so you'll make a block at the top, in the middle, another one in the middle, and then at the bottom. And then we can check out, that's the next step. And you can see that once we have the block set out, we'll divide those blocks into the number of treatments we have. In this case, we're doing 4. From there, you're going to want to assign that block, the plot or, section of the block with a randomized treatment. And this could be something as simple from pulling out of a hat or using Excel, which I will show in a bit. And you would also assign plots to those. And so here you can see that block 1 has all 4 of our treatments. And that is because we want to expose our treatment to all the possible conditions in our area. So block 1 through 4 each have A, B, C, and D, but they're organized differently. So that's where the randomization comes in. So this is the very beginning. And then from here, you can create a map that can help you organize your plots for when you're actually out in the field. And so I'll be showing a quick Excel demonstration to show you how to do that randomization function that I mentioned. First, identify your columns as random function, treatment, block, and plot number. Here, you will be inputting equals rand, parentheses, and then a random number comes in. Here in the treatment, you would want to put all your treatments, and you will repeat this for as many blocks as you have. So remember, we have 4. So 1, 2, 3, and then 4. 4 blocks, 4 treatments, and that's what determines the amount you will be repeating. And then you can just copy and paste this, copy and paste this, and then copy and paste this. And you saw that this whole time the number was changing. That's good. That's going to make our treatments be completely randomized in a bit. And then from here, you're just going to double click in the corner so that this can extend all the way to the bottom. Here, you're going to want to highlight from this corner and highlight only the block 1. You want to randomize within each block. If you were to highlight everything, it would randomize everything, and you might have all your A's in block 1. And so you want your block 1 for each of your blocks to have all 4 of the treatments. You highlight it, go to data, sort and filter A through Z, and you can see that your treatments have been randomized. And you would repeat that for each section, sort and filter, and there we go. The 3-digit system that I mentioned for the plot numbers, it would be that for block 1, you have 101, and then you have 102, 103, 104. But when you jump to block 2, you wouldn't go into 105, you would go into 201. It's kind of an easy way to remember where your plots and your blocks are, and the same thing would happen here, 301, 302, 303, and the same 401, and such. Once you have your treatments randomized within your block, you can create that map I mentioned, and here is a quick example. So this would be something that you print and actually take out to the field to assist you and to make sure that you do everything as you're supposed to do. We see that we have our blocks split into plots, and so the plots are going to be 25 feet wide, 10 long. We have these pathways to walk through, and then something to mention as well, you can see that the treatments are randomized within the block. They all have, each block has all of the treatments. And then you can see that we go from 101, 2, 3, 4, and then we jump here to 201. So we don't start on the left. This is called the snake organization, and it makes it easier for you to walk down the plot and then be in order every time you give a turn instead of walking all the way to the front. Okay, and then our next Excel demonstration is going to be for ANOVA. So let's pretend that you had a successful experiment and now you have all your data and you collected it. First thing you're going to do is set your columns and your rows. Your rows are going to be the treatments and your columns are going to be the blocks. You input your data in between as you should. Go to data, which we're already at. Click data analysis in this top corner. And then you see that you have a lot of options. Do not worry. I know what we're supposed to pick, and that is ANOVA 2-factor without replication. If this was a CRD experiment, then you would pick ANOVA single factor, but it's not, so we're picking ANOVA 2-factor without replication. Okay, and then an input range. You're gonna highlight your entire data and see how it's already selected. You're gonna click labels. If this was not clicked, then you would want to only highlight the numbers. But it helps to have the label since the ANOVA can organize that and make it easier to read. Your alpha will typically be 0.05, but that can change with experiments. And then your output range, gotta keep these up. Your output range is basically where your ANOVA will be entered into. And so I selected a random cell in here, but you can make a whole new worksheet. We click OK, and that is our ANOVA. This top part is a summary, like the averages and such. This is the part that really matters. So your rows, again, that is your treatments. And then your columns are your blocks. And then to analyze the data, we want to check out these numbers. So if your F value of your treatment, so not this one, that's the block one, of your treatment, this top one, is greater than the F critical, then you have significantly different data. If your p-value that's given here is smaller than the p-value or the alpha you selected for your analysis, that also means that your treatment or your experiment had significant difference between the treatments. If these were not the case, then that means that there wasn't enough difference between your treatment to statistically make it significant. You could also, after this, go further into analysis by doing HSD, which we will not be doing, but you can check out Hossein Zachary's amazing YouTube video for a step-to-step guide. And then I forgot to mention what this would mean when there's significant difference is that you have your null and alternative hypothesis, right? And so if you have significant difference, that means that your null hypothesis can be rejected. And that means that there is difference between the treatments. Okay. And then here is a real world example. This was during my 490 class in which we actually went out to a field and set up our plots. We used a map similar to the one I showed in this video. In this picture, you can see the measuring tape set out so that we can measure exactly what 10 feet and 25 feet are, and those pathways, the 2.5 feet. We used spray paint to mark the corners. You can see here in the background, and you can also see it here. Additionally to these, we put flags to make it easier to see. And then here, this is me. You can see me smashing the wooden planks into the ground where we put our labels with my water bottle. You know, it served as a great hammer. Once you have labeled your plots, you can take out these flags, which we hadn't done here yet. But this is also me celebrating after we were the first group to finish the whole setup. And so here is the summary. And so that was a quick run on what RCBD is. And then for the summary, so we covered what is RCBD, how RCBD and CRD are different, how can we eliminate the variability in a field, how do we prepare those plots, and how do we analyze the data through Excel. And thank you very much for watching. I hope you enjoyed and that you learned a lot.